Welcome children to the virtual chemistry class. Today we'll discuss about energy change during chemical reactions. Now, in every chemical change there is a change in energy is involved. It is only due to the difference in chemical energies of reactants and the products. Now these differences between the energy of reactants and products are only due to the strength of chemical bond present in the reactant and the products. As we know that energy can neither be created nor be destroyed, and thus to maintain the equilibrium between the reactants and products, the energy may be evolved or may be absorbed during the reaction. Now this energy can be in the form of heat, light, sound and electricity also. So this is the definitions of the chemical energy. Every substance has a fixed amount of stored energy which is in the form of potential energy, which is referred to a chemical energy. Now during the chemical reaction, the chemical bonds breaks for the case of reactants between atoms, and new chemical bonds are formed between the atoms to produce product. Now if the types of energy are different for each other, there is either a surplus or a deficit of energy during the reaction, and thus the energy may be absorbed or released. As a result, chemical reactions can be broadly classified into two categories. First is exothermic and second is endothermic. First, exothermic reaction. When heat energy is evolved, it will be termed as exothermic reactions, and it causes a rise in temperature. For example, when carbon burns in oxygen to form carbon dioxide, a lot of heat is produced. Look at this. For a case of exothermic reactions, it is written on the product side. Heat, it is not the product, but the change in energy. Now for these exothermic reactions, the heat evolved, so it is written as a plus, but enthalpy of reactions, enthalpy is a thermodynamic terms. Enthalpy is a sum of internal energy of a system and product of pressure, volume, work. For the exothermic reactions, enthalpy, it is also a special type of energy. Enthalpy, this is the product, this is the sum of internal energy of a system and the product of pressure, volume. This enthalpy for these exothermic reactions is negative, but here the heat is positive. Combustions of natural gas, it is in another important sources of energy, and these combustions is exothermic in nature. This is for the case of methane. You can write propane, butane, ethane also. These are all exothermic reactions. If a hydrocarbon on combustions gives a lot of energy which can be used in industries or home, then the hydrocarbon will be referred as a fuel. The amount of heat energy evolved, sometimes may be referred as calorific value of that fuel. Calorific value of the fuel. When water is added to quicklime is the calcium oxide, a lot of heat energy is produced with the formations of alkaline calcium hydroxide, which is termed as slaked lime, and huge amount of heat is evolved. After some time, the solutions or the mixtures will start boiling due to the huge amount of heat energy is evolved. Now, formations of water is also a case of that exothermic reactions. Next, combustions of glucose with oxygen in the cells of our body provides energy. Since it provides energy, it is exothermic, and this biological process has some special name which is termed as respiration. Next is your endothermic reaction, a chemical reaction in which heat is absorbed is called endothermic reaction. It causes a fall in temperature. In this case, the reactant needs heat energy, external heat energy is required because of these formations of this product. Now, these reactions cannot be sustained without supply of energy from an external source. For example, when carbon react with sulfur, it will produce carbon disulfide. Heat energy is required. As a result, after the reactions, the temperature will fall. Similarly, nitrogen and oxygen are heated together to a temperature of about 3000 degrees centigrade. Nitric oxide gas is formed. This is also an example of endothermic reactions. Calcium carbonate decomposes to carbon dioxide and calcium oxide. This is another example of your endothermic reaction. So calcium carbonate, when heated, calcium oxide and carbon dioxide is formed. Next important examples is your photochemical reactions. It is the special type of reactions that occurs in absorptions of light as a source of energy. According to the Planck's quantum theory, each and every light contains some energy packet, which is typically termed as photon. On absorptions of photon, these types of reactions will occur. For example, when carbon dioxide react with water in presence of chlorophyll and sunlight is termed as H nu, absorptions of photon, H nu 1 photon into 6.022 into 6.022 into 10 to the power 23 into H nu is the amount of 1 Einstein energy. H nu is the frequency of that photon, H is the Planck's constant, H nu is the energy of 1 photon. If H nu into 6.022 into 10 to the power 23, then it will be termed as a 1 Einstein of energy. 6 CO2 plus 12 H2O gives you glucose plus water plus oxygen. This reaction is termed as photosynthesis. Another example is when silver nitrate, when irradiated in light, diffuse sunlight, it will produce silver, nitrogen dioxide and oxygen gas is evolved. The next and the last term of your chapter is electrochemical reactions. As the name suggests, these type of reactions occur in absorptions of electrical energy. For example, water breaks down to its constituent hydrogen gas and oxygen gas in presence of electricity, when you place that platinum electrode in acid diluted water, fused potassium chloride breaks to its constituents K plus and Cl minus when electricity is passed through it. All these reactions are termed as electrochemical reactions. Similarly, when solutions of copper sulfate, actually Cu plus 2 plus SO4 minus 2, these two are the basic components of copper sulfate. When its solutions is electrolyzed at cathode, copper deposited. This is an example of electrochemical reactions. Copper deposited if we use platinum electrode. If we use copper electrode, then copper sulfate solution breaks to produce copper deposited on the cathode, and the anode, from the anode copper destroyed. So this is the decay of the copper anode, and this is the depositions of copper into the cathode. If we use the attacking electrode, that is copper electrode, but if we use platinum electrode, then anode will not decay, rather it will form an oxygen gas. So the products of electrochemical reactions also depends on the nature of electrode. Electrode may be attacking or electrode may be inert. In higher class you will learn about these things. Electrode, the product of electrochemical reactions depends on electrode. So we came at the end of this chapter. Is a short review of this chapter. We have learned combination reaction, we have learned displacement reaction, decompositions reaction, double decomposition or double displacement reactions, neutralization reaction, precipitation reaction, and in this video we have learned about exothermic and endothermic reaction. Okay children, stay safe.